Hi, everyone, and welcome to SARMAC. I am so thrilled to share the science of learning with you today. I'd like to start by thanking the SARMAC committee, especially Kim Wade and Rob Nash, for all of the hard work they've been putting in behind the scenes to make SARMAC happen this year. I'm Dr. Pooja Agarwal. I'm a cognitive scientist. I've been conducting research on how students learn for about 15 years, and I am so excited to share with you some of that research and also how we can apply it in the real world today. So let's go ahead and get started. So to begin, I wanted us to think today about what it means to be memory researchers. Whether you conduct research like I do on learning and memory in the context of education, or maybe memory when it comes to eyewitness testimony, lineups, false memory, we all are fascinated by how humans retain information. What I'd like for you to think about today is how you yourself retain information. What is something you really struggle to remember? So, for example, I really struggle to remember the conversations I have with friends and family about what's going on in their life. My episodic memory, not so good. My semantic memory, great, no problem. I can remember facts, dates, and names. What is it that you struggle learning about and what you struggle remembering? Specifically, we're going to talk a bit about how we can improve students' learning and memory and how we can improve your memory of SARMAC. As we're spending these number of days together, what can we do to make sure we're getting the most out of it? Of course, SARMAC is going to spark some interest, some new research ideas, but today, how can we make sure that we're remembering what we're learning? So what I'd like to do is talk about one, applied research in learning and memory, specifically a strategy we call retrieval practice. Second, I'd like to talk about how we apply retrieval practice and this research in the classroom with teachers. Third, I'd like to share some ideas and thoughts about the importance of communicating our applied research for practitioners and to share it and communicate our science with the world. So a very simplistic memory model that a lot of us are familiar with and know that it's simplistic is this three-stage model from the 1960s. The first stage being encoding. How we as humans, as people, as students, how we get information into our heads, how we encode what we're learning in a classroom, what we're learning here at SARMAC. That's the first encoding stage. The second stage in this memory model is storage. We hope that we encode information, our students encode information, and that it gets stored. It gets stuck somewhere in there. And then the third stage is retrieval. Can we pull that information out from our minds? So in educational context, this might be a midterm or a final exam, or it might be in everyday life when we're just trying to remember what are the details of that movie I saw last time or my favorite vacation. That's retrieval and pulling information out. What we've learned over the years from research in educational context is that teachers typically focus on getting information into students' heads, that first stage of encoding. And what we've learned more and more recently is a key component of learning is the third stage of getting information out. That retrieval stage helps strengthen our memory. It's not just for assessment. It's not just to output what we've learned, but by going through that retrieval process, we're re-encoding information and it's strengthening that knowledge. Now, we know that here at SARMAC, that retrieval influences false memory. It influences what we remember from events. Again, in classroom settings, we want to help reinforce that sort of truthful, accurate knowledge memory. One example of a simple retrieval is trivia facts. Maybe you really enjoy Jeopardy, you enjoy pub trivia. One trivia fact I love is this question. How many bones are in the adult human body? I'd like you to take a moment and try to bring this information to mind. Take a guess. You can tweet your guess. You can share it with someone next to you. You can retrieve and write down your answer. Don't cheat. Don't Google this, but just retrieve. How many bones do you think are in the adult human body? The correct answer is 206, 206 bones in the human body. We'll continue to come back to this idea and trivia fact as well, but again, it's just an example of retrieval practice, bringing information to mind. So we know that this process of retrieval, again, improves students' long-term learning. There's been a wealth of research about retrieval practice. You may be familiar with a landmark study by Henry Roediger and Jeffrey Karpicki in 2006, for example, and there has continued to be this boom of laboratory research and applied research on retrieval practice. In educational context, retrieval practice could look like short quizzes. It could be in the form of student flashcards, writing prompts. Perhaps you're familiar with entry and exit tickets. Retrieval practice can take a number of forms. What my colleagues and I were interested in was, does this laboratory-based principle improve learning in applied settings? Does it improve learning in the classroom? So my Ph.D. advisor, Henry Roediger, along with Mark McDaniel and Kathleen McDermott at Washington University in St. Louis, had the opportunity to conduct more than 10 years of research on retrieval practice in authentic classrooms. One thing I love about applied research that I hope you love is that it's messy, right? We can control all kinds of variables in laboratory settings, but in applied settings, we can see if something really does work in the real world. So we had to deal with snow days and fire alarms and assemblies and students out sick. But in some ways that helps really put to the test, do these laboratory-based principles also work with real teachers, real students, real classrooms? So over the course of that 10 years of research with basic retrieval practice methods, specifically low-stakes quizzes that at the time we used clicker quizzes, where students had clickers and they would get multiple choice or short answer questions and write in their answer or click in their answer. And this very simple strategy of retrieval practice raised students' grades from a C to an A. We looked at students taking Spanish, science, social studies, English, and consistently we found benefits of retrieval practice for students grades 6 through 12. We also wanted to look at whether retrieval practice improves complex higher order learning. Of course, a common criticism is, well, all of this retrieval sounds like basic memorization. We have found that retrieval practice improves higher order learning for college students and for middle school students. My colleague Andrew Butler has demonstrated that retrieval practice improves student learning in advanced engineering classes. And my colleague Doug Larson at Washington University demonstrated that when students engage in retrieval practice, brief quizzes, they increase their ability and accuracy to diagnose neurological disorders compared to when they simply reread a textbook. So we know that retrieval practice works, that it improves students' long-term learning, and because of that continuing laboratory evidence, we're now seeing this boom of research in applied settings. So my colleagues Ludmila Nunch, Janelle Blunt, and I wanted to look at, well, what about across all of these different applied settings, does retrieval practice still consistently benefit student learning? So we recently published this review of the literature in Educational Psychology Review. And what we did was we screened more than 2,000 abstracts in the literature, and we limited this to just classroom studies where the instructor was present the student was engaged in retrieval. So importantly to us, we excluded any research where students were self-directing their own retrieval practice outside the classroom, as well as collaborative retrieval. Valuable types of retrieval practice, we simply focused on individual retrieval in classroom settings. And our total sample size was about 5,000 students, ranging again from about 4th grade on through medical school. And we looked at a variety of factors affecting retrieval practice: the educational level, whether it was middle school, high school, college, etc., the question format, multiple choice or short answer, the timing of retrieval practice, all of the different variables that we could code from about 50 experiments. What we found was, first of all, the majority of effect sizes we were able to extract demonstrated medium to large benefits of retrieval practice in classroom settings. So a robust, consistent finding. We were surprised and disappointed that only 3 out of the 50 experiments we identified were conducted in non-weird countries. So weird standing for Western, educated, industrialized, rich, democratic countries, meaning that 47 out of our 50 experiments were conducted in the United States or Western Europe. Only 3 experiments were conducted with diverse samples, which were in Taiwan, Turkey, and Pakistan. So we'd love to see more applied research in this area, and probably more applied research in your area with diverse samples around the world. We also noticed that some holes in the literature, both laboratory and applied literature, included research on pop quizzes when retrieval practice was unanticipated for students, again with diverse samples, and specifically with non-science content. A lot of research to date has been conducted with psychology content or biology chemistry content. So we'd love to see more applied research using non-science content. Importantly, especially from an applied perspective, we found that it didn't really matter what the question format was, what the specific timing of retrieval practice was, how many quizzes students got, there was still a consistent benefit. So oftentimes I have teachers ask me, well, how often should I give retrieval practice? Or how many points should it count toward? And we were glad to see these consistent benefits across 50 experiments in a variety of content areas, educational levels, simply demonstrating that pulling that information out from mind improves and strengthens students' long-term learning. So there's just a tiny bit of the applied research going on in the area of retrieval practice. I'd like to now share what that applied research means in the real world in terms of teaching strategies. How can we take that research and really inform what practitioners are doing on a day-to-day basis? Now, before we talk about teaching strategies, I wanted to give us that trivia fact again. Mentally retrieve, travel back, bring that information to mind. How many bones are in the adult human body? At this point, I hope you remember that it's 206, right? So imagine how simple retrieval practice can be in the middle of class. Another example is so often we start our classes by saying, here's what we did in class last week. And that's a form of encoding, that first stage that we had talked about, that's getting information into our students' heads, reminding them what happened, but a simple switch to really more effective, robust learning is to simply ask students to retrieve. What did we do in class last week? That's retrieval practice. And what I find so compelling is that doesn't require grading. Students don't have to turn in a paper. They can write this down, they can chat with someone, they can put it into a chat online, but simply asking students to retrieve, what did we do? As opposed to just reviewing for them, makes a big difference for the start of class. So I hope you'll consider that as you teach students. Another strategy that's been widely adopted is called a brain dump. In the scientific literature, we call it free recall, but it's simply asking students to write down everything they can remember about a topic. So for example, if a middle school history teacher has just taught students about ancient Egypt, is to have them write down maybe the end of class or later that week or later in the semester to write down everything they can remember about ancient Egypt. That brain dump, simple retrieval, we don't have to grade it. It can take 1 minute, it could take 5 minutes, or you can let students continue to brain dump as long as they can. Now that could serve as a quiz or an exam as well, but we encourage thinking about retrieval practice as a low stakes opportunity to focus retrieval as a learning strategy, not an assessment strategy. Another approach to retrieval practice is what I call 2 things. Simply asking students to write down 2 things they can remember. What are 2 things they can remember about the class on developmental psychology? What are 2 things they can remember about a statistical formula? And this could be done at the beginning of class, at the end of class, in the middle when things are kind of dragging, is to just take a break and have students retrieve and move on. And this really can take 1 minute or less. I'm a big fan of handing out index cards to students. That way they can hold on to them. You could collect them, shuffle them, hand them back out. It's an easy way for students to retrieve. Another thing to keep in mind that you may use in your own classrooms is think, pair, share. We ask students to think about a concept or a discussion question. We have them pair up and then they share with class. An important critical thing to keep in mind with retrieval practice is to not skip the think stage. Sometimes we are so eager for students to get into the pair and share because it's engaging, it's active, but make sure students are retrieving and thinking first before they move on. Don't skip that step. Okay? So here are some of my college students. I teach at the Berklee College of Music in Boston. I'm not a musician. I get to teach science and psychology to musicians at Berklee, and I absolutely love it. I teach about 100 college students every semester, and I provide retrieval practice in a variety of different ways throughout my classes. One of the ways I really emphasize retrieval practice is with weekly low-stakes quizzes. This is either written or I use Google Forms, and they're worth only about 10 points out of 400, but eventually students get really comfortable and really enjoy these retrieval practices. So some quotes I've received on student evaluations I wanted to share with you. Again, we have the applied research to back up the strategy. It's nice to see how this works in the real world. So my students have said that retrieval practices are the bomb. They love them, which is pretty fun for me to see, and that they love that we don't have a midterm or a final in my classes. I emphasize this process of remembering and retrieving every week instead of just cramming for a midterm and a final. Another way I put it to my students is I want them to remember this experience and what they learn in my class. What's the point of a 15-week semester if 2 weeks after that they can't remember anything from my class? By retrieving every week, they're going to remember more than if there's this sort of easy learning from cramming. So a quote I love from Make It Stick by Peter Brown, my advisor Roddy Roediger, and Mark McDaniel is that learning that's easy is like writing in sand. It's here today and gone tomorrow. We have to challenge ourselves to retrieve. We have to challenge our students to retrieve. So to come back to that first question, think about what you want to remember from SARMAC. Again, maybe it's a research idea, something you found super fascinating in a session or a poster, some ideas to really engage yourself in your own memory. You can retrieve at the end of a session, at the end of a day, at the end of all of SARMAC. Imagine at the end of SARMAC doing a brain dump and writing down everything you can remember. Of course, there are a variety of ways you could do this as well. You could start a Google Doc. It might be neat for your lab to create a collaborative Google Doc. You can, of course, write this down on paper and pencil. You could even consider tweeting one thing that you've learned at the end of the day. So a variety of ways to make this easy on yourself, but to make sure you get the most out of SARMAC while you're here spending time together. One more thing I wanted to touch on is the importance of science communication. I think applied research is so fascinating. Laboratory research sets the foundation. It serves such a critical purpose. Applied research tells us what happens in the real world, and we need to make sure that we are getting that information out there. Otherwise, it just kind of stays inert. Some other reasons why is to trust that you have research to share. I saw some interesting sessions listed about tattoos and autobiographical memory, of course, fake news and false memory, lineups, eyewitness testimony, the pandemic, learning from Zoom. We have some cool stuff and we need to share it. One of the great things about sharing science in our field is forming unexpected collaborations. I've been fortunate, for example, to form a collaboration with scientists in Brazil. And I wouldn't have done that if it weren't for me sending out a few tweets and some of the collaborators to just reach out to me. And now we've conducted research and published together. So by science communication, you'll get to meet other people. And of course, by learning, especially from our rich international SARMAC community, is gaining insight into new research questions. So in my case, retrieval practice seems robust. Most of that research has been conducted in the United States. What might it look like in Brazil or in another country around the world? So making those connections are key. Of course, it's easier said than done, I think, or can be. Some ways to start small include just Googling SARMAC speakers. If you go to a session, it seems really neat. Google them and see what they're up to. One other way of science communication, it may be uncomfortable for us to share our unfinished science, or we might be worried about getting scooped, but you can share other people's resources. Maybe you create a list of your favorite books on false memory, or you create a list of websites and blogs that you really enjoy. So you can share other people's work if that's more comfortable than sharing your own research. This sounds a little wonky, but I'd encourage you, if you're recording your talk or you have a PDF of your poster, is to send it to family and friends. My family still does not know what I do professionally, but it'll be a lot of fun for me to send them this video and for them to get a sense of what I'm excited about. Your family and friends would love to see that. So even if you're uncomfortable posting a video on Facebook, just think about sending it to a few friends and getting their reactions and talking about it. I also want to mention, for many, it's intimidating to think about tweeting, and I wanted to recommend going to this URL, twitter.com/#/SciComm. And there you can see how scientists around the world are sharing their science. You don't need a login, you don't have to tweet, you can just go straight to that URL and see how other scientists are engaging in other types of scientific communities beyond just their area of research. So you really can start small to give our science away. So to wrap things up, I wanted to bring it back again. Think about your time here at SARMAC. Really, what do you want to get out of it? So often we sit through conferences, it's a one and done. You do it, you're energized, and then a week later, you've forgotten everything. Think carefully and retrieve and remember this experience at SARMAC. Last question, how many bones are in the adult human body? I hope that that is one thing, if anything, you remember from SARMAC, it's 206. So thank you all so much for your time here and your time during SARMAC and for sharing the science of learning and memory with everyone. Thank you so much.